Okay. Assalamualaikum and very good afternoon. So can you all hear my voice?
Yes, doctor.
Okay, good. Then for those who are already in, so please scan your attendance. Okay, because I'm going to close or deactivate the attendance within 15 within 15 minutes more. So, okay, so please, for those who are already in, please scan your attendance because I'm going to close the attendance screen because I cannot share two tab at the same time because after this I'm going to open the open board and my lab. So please scan the attendance. So far there's already 17, but the attendance here is 19, so another 2% haven't scanned the attendance. Okay, please scan your attendance yang baru masuk tu. Okay, done. So I'm going to deactivate the QR code now. Okay, so next time please when oh, okay, Hafiz, those who are just joining, so please scan your attendance now. I'm going to deactivate the QR code now. So next time, please, when I say the class is start at 2:15, make sure you already join the link that I gave you before 2:15 because when I mean 2:15, meaning that I'm at 2:15, I'm not accepting you. 2:15, I would like to start my class. Okay. So starting next week, starting next class, so please do so because when I say 2:15 and then 2:15 start coming in or joining the class, then I have to wait some more. I cannot start the class at 2:15. Why? I mean 2:15, 2:15 I'm going to start lecturing. So yang mana baru masuk ni please scan your attendance. Okay.
Doctor.
Yeah.
So around 2:15, usually we enter the class like 5 minutes early or something.
Yeah, just join the link earlier because even though that I haven't approved you, you're still innovating. It's like you are innovating it so that you already queuing to enter the class. I just need to click and click the accept button once only. But if I say 2:15 and then everybody start coming in one by one, so I have to click one by one for those who would like to join my class, and then of course I can if I've been clicking one by one, I cannot start my class straight ahead, right? Okay. So next time, when I say 2:15, so please join earlier before 2:15. It's just that even though that I haven't approved it, it doesn't matter because I just want to click only once so that everybody going to come in at the same time lah. Okay. But kalau more 2:15, then starting 2:15, you guys just come in one by one. Then I have to click one by one. Okay. So I cannot start my class at 2:15. Same thing if I sit, same thing. Previously, I say that at 2, and then students start coming in at 2, one by one, and then I can only start my class 15 minutes after that. Same thing with this one. And when I say 15 minutes, and then it's everybody coming in at 2:15 one by one, and I can only talk about, I can only start my class at 2, uh, 15 minutes after that or 10 minutes after that. So please, next time when I say 2:15, the class start 2:15, so please come, just click join class earlier so that at 2:15 I'm just going to click once so that everybody going to come in or joining the class at 2:15, and then I can start my class straight. Okay. Okay.
Understood.
Okay, sir.
Okay, good. So now we're going to continue our class on what we are supposed to learn, the tools that you're supposed to learn in order to deliver your project, because you are the first batch that going to they need to take two auto design subject, 81 and 82. So basically, roughly, okay, I'm going to the grades one. Okay. So basically, in our last class, for studio class with me, I already briefed you the whole plan for this subject for 81 and 82, what you are supposed to deliver, and in order to deliver that work, at least you need to learn something, and that's something that you're going to learn more in this semester, which is we're going to focus more on the Simulink, MATLAB Simulink Arduino, and then the SolidWorks and the SolidWorks motion analysis for the FAA analysis or the CAE. Okay, so far all of you already formed your groups, right?
Already, Doctor.
Okay, okay, good. Okay, so last week we already start a little bit on the introduction on MATLAB Simulink. So basically, yeah, more during the approach in my class. Basically, I'm going to give more examples, and then I'm expecting everybody to do it. And then since that we are in these PKP pandemic, and then these online classes, so I cannot make sure that everybody's doing what I'm asking you to do. So basically, I'm hoping that you are going to be sincere to yourself. So when I say please do it, so please do it, because if not, later on, even though I already taught you, for those who didn't do it, usually they will come back and ask me the same questions over and over again, even though I already shows and explained for many times. Okay, but if you really did do it, and then you just still want further explanation, and then it's okay, doesn't matter, you can ask me. Okay, but for those who didn't do it and then come and then keep asking the same question to me, itu saya I'm not, you're just going to to slow our progress, okay, throughout this semester in terms of learning this thing, because basically for this MATLAB Simulink, for SolidWorks motion analysis, these are not the things that you're supposed to learn these things on your own. Okay, you're supposed to learn this thing on your own, because what you learn in your subject is just the theory and then some of practical. But when it comes to real application in the industry, okay, for the core engineering design, usually they're going to use MATLAB, they're going to use MATLAB Simulink, and then they're going to use the CAE software. Usually, most for the R&D department, they're going to use the CAD and CAE software. Either that CAE or CAD model, CAD software is the SolidWorks or SolidWorks Motion. It's just that if they are using different softwares, then you have to learn. But since that you already have the basic or the fundamentals, or you already done it before, learning a new software is going to be easy. Okay, for example, right now you already learn how to use SolidWorks. So when you work in industry, the only software or CAD software that your company got is the CATIA. So it shouldn't be no problem for you to explore these CATIA for CAD modeling. Okay. So for today, we're going to continue on the MATLAB Simulink. So last week, I already made a simple example on the Simulink, maybe 2 questions, and then you develop in a MATLAB Simulink environment. Just that note, I didn't save it with me. So I'm going to make a new notes, a simple notes on this note that I made last week, and I already shared with you. But hold on. Okay. um what Okay, so basically this data flow programming. um is coding IE, so C++, Python, and etc. Okay. Okay, so basically, for the MATLAB Simulink, I'm going to recap back what the introduction on MATLAB Simulink. So MATLAB Simulink is a data type of data flow programming. So it usually an alternative to the type-based coding or text-based programming, which you learned before in your first year in what engineering programming, if I'm not mistaken, and then you learn about the C language as well as the MATLAB coding. Okay, that is actually text-based, and I believe that what you learn is just introduction. There's no specific application that on what you learn during your first year, and but for your ID design, we're going to start learning on data flow programming. And the purpose we are learning data flow programming is actually, and the purpose that we can what show you the shortcut to do the programming with Arduino. Okay, because for this method, if I am asking you to learn the Arduino as well as the programming, and then you're not going to be able to deliver the project properly, because most of the time we'll be focused in learning the software or be learning how to do the programming. Okay, which is in fact it's not efficient, because this programming, let's say for the what electrical and mechatronic students in FK, in SKE, in computer science school, their students are actually been learning this programming of C every year. Almost every semester they have this kind of programming language, so they're quite competent. But for you guys, learning programming is not your key subject, or main subject. So you only have one semester, and then you need to deliver a complex project, which is going to take some time, or you need more extra effort to learn the software itself. Whereas for this subject in auto design, what we emphasize is only learning the method of engineering and then produce the output. Okay, and we are really me, myself, and Dr. Izari, we are really concerned about the output that you are about to deliver during your AD2. Okay, because we want, what we would like to see is your output, your overall output. Okay, throughout this AD1 and AD2, we're not going to show you how to do the programming in terms of text-based coding. Okay, so to do so, to be fair, and then we also going to be fair with you guys. We're not, even though that we are not teaching you the text base, but going to show you how to learn how to do the shortcut for programming to use Arduino to control your system. Okay, so this is what we call this is the purpose of data flow programming. Okay, data flow programming is just it's a simple, it's like a shortcut to do programming, but in terms of its function, it cannot do programming as complex as the text-based coding. Because if you see in text-based coding in C, C++, can what type decoding up to millions of lines. Okay, daripada ni memang millions of lines lah, but if you want to do that kind of programming with MATLAB Simulink, it is not suitable, because MATLAB Simulink is it just going to cause your system is to slow down when you try to compile and run. Okay, it's just that for MATLAB Simulink we just run for specific small system or small functions, not that too complex, then it's fine. But for the whole programming, like what for C, they want you need to, if your system or your programming or your software, you want to design specific software that run a lot of features, a lot of functions, then you need to use text-based coding. Okay, itu awak kena belajar lah, you have to learn. Okay, now for text, and then another thing that you can see in data flow programming. Okay, right now I'm not sure either did you learn about PLC, programmable logic control in your subject, in your past subject, in past years? PLC. Anybody heard about PLC?
No, doctor.
Tak ada. Okay, tak ada. Okay, ini PLC ni satu lagi, dia data flow programming. Usually kalau awak pergi kerja kat luar sana kan, awak akan kena belajar lah pakai ni, sebab for usually most of the industries, they will use this PLC for the automation. Okay, nowadays you only heard about recently Arduino or Raspberry Pi, it just become famous because the IoT kan. Before the IoT phase, we use PLC, programmable logic control, but this subject supposedly being taught or being introduced to you in the instrumentation lab, but I'm not sure why. I think they have the module, but I'm not sure why not being teach in lab, because this one is very important, because the students in the school of electrical engineering, they've learned this. Okay, this is for the automation, because this is more robust. It delivers the same function like the Arduino and Raspberry Pi. It's just that to program this one, they use this one, data flow programming, with using their own blocks lah. Okay. Okay. Alamak. Okay. 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 Okay.
Doctor.
Yep.
About the Arduino, Arduino programming, are we going to implement it on next semester, atau we are learning it in this semester as well?
You're going to learn it for this semester to implement it for your next semester.
Okay.
Okay. For next, I'm not going to teach the how to use the software anymore next semester, because next semester I'm just going to focus in assisting you guys in delivering your project, because next semester you need to fabricate your design.
Okay.
Okay. Because if you don't learn it right now, and then next semester, it will take time. The first one to teach you, and then to make you understand, and then to make you be able to apply this thing specifically for your case. Okay, kalau awak tak belajar, if you don't learn this semester, then next semester is going to be very hectic lah. Okay, we try to delegate your workload for this semester and next semester, so that yeah, this subject won't be too hard for you guys. And then everybody can pass this subject at the same time. So okay. Okay, any
Okay.
other question? Okay, any other question? Okay, good. Okay, so this is just some things on the MATLAB Simulink. So basically on MATLAB Simulink, okay, page. So I'm going to start new page. Okay, so this, I think last time we already did a simple example, example one. I'm not sure the equation. Maybe 5x plus y equal 5x plus 10, if I'm not mistaken. So from there, we're making a new block. So the first one, constant block that being has a 5 value in it, and then another constant block of x, and then these two blocks being multiplied using the multiplication block in MATLAB Simulink. Then this term of 5x, we add it up with the constant of 10, and then this is 10. Okay, this is the display block. Okay, so this is just a simple example last time. Okay, this is display block. And then rules that you need to remember. Uh, okay, you need to remember in order to develop, to represent a mathematical equations into a Simulink block. You need the first one. The signal flow always flow from left to right. Signal flows from left to right. Okay. So therefore, you need to make sure that your equation, uh, you need to rearrange equation with what input at left followed by output at right. Okay, understand? So this is the okay. This is another rules that another rules we're going to implement it when I'm going to derive a specific equation that represent a dynamic behavior of a system. So for a moment, to represent a mathematical equation into a Simulink blocks, we use these rules. So you need to know that you need to remember, put this in your mind, that signal flows in Simulink. The signal always flow from the left to the right. Okay, from here to here. So meaning that if okay, from here, so signal flow from here, from left to the right. So let's say that along this data flow, so meaning that something that there is some error. So for example, that we put some block and that block hasn't been defined its value, the signal flow, it will stop. It will cause your simulation to stop because an error, because of the error. Okay, and then for that, you need to make sure that your equation need to be arranged in a form that the input always being located at the left side, and the output is going to be located at the right hand side. Okay, so meaning that 5x plus 10 go to 1. Okay, so you need to do this one. Okay, understand? This is we already covered this one last week. So any question? So
Tak ada, brother.
okay, so for this week, we're going to go to a even complex equation, just for the purpose of introducing you guys on how to develop Simulink block when involve a complex mathematical equations. Okay, ya, ada orang nak masuk ni. So for example two, we will have another equation. So this one you need try 3x square plus 5x plus 10. Okay. So okay, I'm going to do it for you. Just I'm going to sketch the diagram, possible diagram. So you can do it after this with your own Simulink. Okay. So basically, if you want to do this equation, um, so of course, yeah, we can. But this one, for a simple example, just going to do it for you. Later on, you need to rearrange yourself in your head. Okay. So basically, you're going to be. So this is your x. Either you, okay, just a simple direct. So u square multiple by 3, or you can multiply it with a gain or multiply with a product of multiplication. It doesn't matter. So you need add up with 5x. Bring plus plus. So okay, if you take a look closely over here, okay, especially for this one, okay, take a look at this term where we have x, the input for this equation is using the same parameters, which is x. Okay, when you want to create this Simulink block which represent this equation, so you have two options. Either you use the same constant of that parameters. You can copy like this. Just that you later on this parameters going to be defined in your MATLAB interface. Or what you can do is that you can just simply take the input of x. Oops. From here to here. Just pull your signal line to this point. Okay. Okay. Next one, we just need add up with another one. So, okay. Plus plus, then another one, which is 10. Okay. This is your y. Is your display. So this one being represented by this color, then this one being represented by this color, and this one is being represented by this color. Oops. This color. Okay, any question?
Doktor,
Yeah.
untuk yang dekat 10 yang plus-plus ni boleh masuk juga tak yang dekat yang dekat apa 5x yang 2 ni? Ni
Boleh. Kita nak. In fact, if you want to do if you want to do this term, so meaning that right now we have 3 plus, right? 3x plus positive 3x squared, positive 5x, and positive 10. You can just straight ahead use like this. For example, so meaning that can no problem. You figure. So this one is 10. So this one is from sorry. So this one you need to take the from here, and then this one you make block for this one. No problem. It's just that by this it's up to you, but I prefer to make like this because later on this one is a simple equation. Yes, it's going to be easier for you to do like this. But later on, if you have a lot of equations and things getting haywire, okay, you need to do step by step. Okay, because later on, if let's say there's an error in your when you are try to run your system, you can trace the flow of the signal easily over here and over here. Okay, that's the purpose I'm doing like this. Okay, if you want to do like this, doesn't matter. But if you did like this, make it a practice. It's going to help you a lot when you are trying to develop simulation model at the involving lots of equations after this. Okay. Okay. Thank you for asking. Okay. Thank you. Ada lagi question? Any other question?
Doctor,
Yep.
is there any difference between using the absolute for U or with the blank one?
No. Tak ada beza pun sebab this one is actually the symbol that actually being shown in the the math function under the math subcategory lah bawah tu. If you take a look at the scroll down for math function for the square, after you select the square function, so the block going to looks like this. Okay, absolute U with a square with power of 2. Okay, U, this one means that U means the input, so whatever U is the input, so whatever that goes into the input port at the left side is going to be processed. Okay, understand?
Yeah, understood, Doctor. Thank you.
Okay. Okay, any other question? Okay, now I want you to do open your Simulink and try to do it this block or for this equation now. So I'm going to try to do it right now. It's just a simple one. I need to make sure that you're clear about this one before we start going to solving complex equation, especially when you involve differential equations. Okay. Okay. Open your Simulink and try to do this one. And then so once you finish this one, try to do the example 3. Example 3. Okay. This equation I just made it up, so I do not know how it's going to look like when we plot it. Okay, it's just that this equation it will work. Okay, try to do this equation one. You finish this one. Okay, I will come back within 15 minutes. So at 3 or 5, I'm going to check randomly. Okay, so please do it because for those who are, please do it because I'm going to call your name randomly. Okay. So any question?
No, Doctor.
Okay, good. And then so please proceed. Sekejap saya nak tengok siapa yang masuk tadi. Okay. Okay, done. Okay, ada yang dah siap? Dia nak volunteer nak tunjuk ke saya.
Dah doktor dah.
Okay, siapa yang nak volunteer tunjuk ke saya?
Saya boleh doktor.
Okay, okay. Good, tunjuk.
Macam ni nak share. Okay.
Oh, sekejap. Saya stop dulu saya punya screen. Okay. Oh, awak boleh share awak punya screen sekarang.
Nampak ke?
Belum ni, belum keluar.
Sekejap ni. Screen. Nampak?
Okay, nampak. Okay, so
Okay.
awak run tak ada masalah lah. So kalau macam ni, 3/2. Okay, good.
Saya lagi
Yang saya kuman? Yang satu lagi? Okay, okay, good. Okay, for your information, kalau you can actually combine these blocks within the same file. So meaning that, for example, the second example being put within the same Simulink workspace or canvas, and then it should be okay. It won't be no problem. Okay.
boleh.
Okay, just copy je. Unless you're using different x value. Okay, when let's say for this like your friend, so we have the parameters is x. So if your intentions that this x is actually using different values, then you need to rename the second x as, let's say, the x1. So just to differentiate your input for these two questions. Okay, if not, if you're assuming you're using the same one, so it should be no problem. Okay, good. Okay, next. Siapa lagi tunjuk kat saya? Thank you. Okay, anybody else would like to share with me?
Lagi doktor.
Okay. Okay. Ada nak share? Mana tadi?
Sekejap ya doktor.
Okay, okay.
Nampak doktor?
Okay, nampak. Besarkan sikit. Okay. Okay, ni 15 campur 3/2, 3 ni yang bawah kan? Okay. Okay. Ni X. Sekejap okay, yang soalan yang kedua ni ada isu sikit lah. So, tak betul lah. Okay, tak apa, nanti saya betulkan. So, awak kena ingat lah, walaupun satu, dia ada dua jenis salah dalam simulation. Satu, there's two types of error that you typically going to face when you are developing a simulation model from equation. The first one, what the real error, meaning that when you do the coding, you do the arrangement for the simulating blocks, and you run it, and this what the compiling or what is run is giving an error, it stops. Or the second one, everything runs smoothly, but it gives you a wrong answer because the way that you do the coding or the block arrangement is not correct. Okay, that two types of coding lah. We need to be very careful. and the second one is very the what is very dangerous one, because it's what we call is rubbish out, because you didn't know that you are doing the right thing. So even though that you give the blocks the input, it still give you the output. So if you not really check it, you're going to assume that the answer is right, which is not, because you need to really check it. Okay, okay, this is the okay for the second one. Yang tadi yang kawan saya yang ni tunjuk tu saya tak pasal block arrangement. Awak tak tunjukkan ni? Yang tadi, in the first one.
Apa dia tu?
For the first equation, saya tak ingat. Okay, tak apa. Yang nanti sekejap lagi awak betulkan. Okay. Okay. Okay, okay. Betul. Saya ingatkan EX square yang atas ni 5X campur 15. Okay, betul. Ni 5X dengan 15 kat bawah. Betul. Okay, betul. Sorry.
Okey dah.
Sekejap. Square dulu. Okay, betul. Ni kat bawah lah. Saya ingatkan yang power exponential power of the function. Okay, good. Okay, next we're going to continue. Okay, thank you. Okay, next one, we start going to do some simple derivation or partial differential equation and partial derivatives. Okay, these are the things that even though that it take to engineering, I don't think that everybody love to solve calculus kind of question. Okay, which in calculus we have a lot of differential equation, we have derivative equations, and then we have partial equation, meaning that if you have a whole set of equation, only certain terms in that equation going to be going to do the derivative or differential. Okay. Okay, next pages. Okay, saya simpan dulu lah. Last time tak save ni. Ni saya tambah lah. Okay. Now, for example, that okay, just what if derivatives?
Doktor share.
Doktor.
Oh, tak nampak. Okay, sorry. Sekejap. Okay, nampak saya punya ni?
Nampak doktor.
Nampak doktor.
Okay, in your previous years, you did learn about calculus, right? You learn about the mostly about how to do the integral and derivative. Integral is apa? Kamiran. Derivative panggil apa? In Malay.
Kamiran tu integration.
Integration.
Terbitan.
Derivatives?
Terbitan.
Terbitan, yes, terbitan. Okay. Okay, ni dah lama lah tinggal kan. Saya pun dah lama lah, lagi lama pada awak kan. Saya tahu pakai sekarang. Okay, so basically in general form, if you have, this is actually general form of derivative equation. So you're going to be in this form d dt, and then we have x. Okay, and dx. Okay, this is whatever it is lah. So we have mathematical function. Let's say that ft lah, fx. Whatever math function, you have is going to be integral. This is the what general form of mathematical equation, and this is the general form of integral equation. So basically, ni tak ada, sorry. Boleh. The integral fx dx. Okay, so this is meaning that if you have a set of equation, the whole equation will be derived, and then if your attention is doing integral equation, meaning that the whole equation will be integrated. Okay, it's just that in Simulink, the sign or the block that we use to do this operation for derivative and integral will be represented by this block. Okay, this one, the latest version, if I'm not mistaken, the u per dt. Oh, sorry. If not, the latest sign is this one. dt. Okay. This one is 1 over s log. Okay. So let's take a look at the sekejap, saya pun baru nak buka screen MATLAB. Sekejap. So since I'm just about to open my MATLAB, so we're going to take time. So can somebody share the MATLAB interface, the Simulink library browser? I'm going to show you the location of this one. Yeah. Okay. So anybody, I forgot to ask, anybody is recording this session?
Yes.
Okay, good. Muaz di ketua kelas kan? Okay, ni dah ada kawan aku bagi kan? Okay, this one, okay, for those yang tak tahu kat mana nak cari, so ni tolong buka link Simulink browser. So this block library browser, buka yang apa screen yang ni, terbuka yang library browser ni. Boleh tak boleh? Okay, okay, this block is actually under the discrete category, Simulink discrete. No, discontinuity. Continuous. Yeah, this one. So you have this. This is actually the most common block that we use to do the calculus operation, either the derivatives function or integral function. Okay. Other than the other block inside this category is actually for advanced features. If you have problem, maybe I can have time, can share with you. But this one is actually the most common operation or operator to perform the calculus function, either the derivatives or integrator. Okay, thank you, Nick. So understand, everybody. So where to find this block, or either if you can also type this the name of the block, so derivative, and also you can also type the name of integral. So you're going to this is actually a shortcut. So before you type this one, of course you need to know it, and to know it you have to find this block manually first. Okay, and then and this is the derivative and this is the integrator. Okay, thank you, Nick. Okay, now I'm going to show. Okay, this one previously example 2 and example 3. Okay, example 4. So this one is okay. So now okay, I have okay. Now you try to do both operation of derivative and integral for this equation. So we have this equation. We have the first one is fx equal to 5x. Sorry, x equals to 5. Yang kedua 5x equal to 2x kuasa 8, x kuasa 8 dan 3 fx equal to 2x negatif 3 4 fx equal to x kuasa 4 x kuasa 3. Okay, what I want you to do is that to create or to represent this mathematical equation into semi block arrangement first before you do both the integral and the derivation function using the integral and derivatives block, and you see the result. And then instead of this time, instead of using a constant, you should use x equal to sine t. So when I use x equal to sine t, meaning that please use sine block. Okay. So for this one, I want you to do the fx dx and d per dt of fx. Okay, understand? Any question?
Ya, yang nombor 4 tu doktor nak yang first tu integrate, yang second
Both. Tak. Sorry. Ini
Oh.
bukannya refer ke soalan 4 je. You need to do this both of the function, integral and derivative for all 4 equation. This one. Okay. Ni confuse sekejap. Saya nak awak buat ni. Okay. Boleh? Faham Okay, faham. So for example, we have okay, let's say that we have design block, and then there is inside the if you cannot find x equals what x power of 5, there is no function in the block. What you can do is what user function. So what you can do is u 5. Okay, this one is a user function, custom function. And then yeah, x5, and then let's say that for the derivatives, so you just put the 1 over s block over here. Okay, and then for this one, same thing, put sinusoidal u5 di apa dia punya sign tadi, dt. Okay, this is your apalah, just put your scope, because this time you're using a continuous input of sinusoidal wave, so for sure you cannot view it using a display block, so you need to put scope. Okay, this is for the first question, and then do the same for the rest of the for the equation. Okay, let me show you where's the block. Let's say that the math function that you want to use, for example, you want to your input to have the power of 5, and there is no power of 5 inside in the MATLAB block. So what you need to do is that you need to write a custom equation or custom in Simulink block. Okay, the block is over here. Okay, let's say only use block constant. Oh no, sinusoidal success sign. So for the sign block, you don't have to change any value here. Just use the default value. Okay, second one is okay, user defined function, which is this one. Okay, this is your okay, use this one function fu. So it's going to be as a function of the input, and you need to know u means that input. Okay, so you just type. Okay, this is the default equation. You can work based on this equation, but based on our function, you just need to type. Always use u. You cannot use other alphabet because it is what a standard symbol for input in Simulink. So use this one. Okay. Then use continuous. Let's say use the derivatives. Then put the scope. Oops, sorry, not import. So since that this is just power 5. So basically just going to give you almost the same trend. Okay, this is the power 5. We're going to give you like this. Okay, if you take a look closely, you can see that the curve for this equation is not that smooth because it's a bit not cantik lah. It's not a very fine curve. This one related to the sampling time that we use. If you to have a good curve, you need to use a very small sampling time, not that small, which usually we use up to only up to 0.01. Currently, the setting being set to default, you use a variable sampling time, meaning that the solver will automatically pick up the sampling time that it will start or initiate the calculation, and randomly it can be start with the value of 0.01 and then jump straight ahead up to 0.5. It's not a uniform sampling time. So, but if you select a fixed sampling time, you use a constant variation of sampling time, meaning that the calculation will be done every 0.01 second. So it will done when you click run, so it will calculate for you every 0.01, and then next at 0.02 second, and then followed by 0.03. Okay, and then by doing that, you will have a nice curve of what scope result. Okay, how to do that? Just change this one. So just click configuration parameters, and then under the solver selection, change from variable step to fixed step. Okay, and then click this one, and then change this one from fixed step size from auto to, let's say, to 0.01. Okay, 0.01. So just apply. Okay, then just run again. You can see that the curve is becoming finer. Okay. Okay. Now do the same thing for the rest of the equation. Okay. Any question? Okay. Any question? Ada soalan?
So for satu equation tu kena buat satu untuk integral and differential lah, betul tak?
Yep. Yep. Correct. Okay. Okay, faham. So the equation awak nak copy paste dia, awak nak buat macam mana ke terpulang lah. Tapi nanti bila saya check, saya nak tengok ada dua scope ataupun ada dua result for function, either it being integrate and either it being derivative. Okay. So 15 minutes. Okay. I give you 15 minutes. So I'll be back at 3:45.
Sir.
Yep.
Kan kalau saya sambungkan yang integral punya blok dari dia apa differential.
Itu saya tak tahulah, awak buat lah macam mana dulu. Nanti saya tengok. Okay. Okay.
Saya dah buat lah tapi tak tahu.
Tak adalah, kalau awak dah rasa dah terror kan, awak buat lah macam mana shortcut yang awak nak buat as long as it's working. But if you want to practice on how to do the arrangement, you can practice repeating, rearrange your block lah. Because yelah, kita buat kerja banyak kali, nanti lama-lama pun akan terror lah kan. Okay. So yeah, it's up to you. Okay. So 15 minutes. I give you 15 minutes. I'll be back within just 15 minutes.
Doktor. Hello. Hello. Okay.
Korang ada problem dengan nombor 3 integral.
Iya.
Hmm.
Ada soalan?
Ada doktor. I think kita semua ada masalah dengan equation yang nombor 3. Integrate. Sorry. Integrate. Ya.
Soalan nombor 3. Okay. Good. Soalan nombor 4. Ada masalah dengan nombor 4?
Sama je doktor. 3 dengan 4 saya ada masalah.
The same thing, you just write it in the user function block. Okay, for example, saya nak 3 dengan 4 ni. Negatif 3, okay. Yep. So, ni kuasa negatif 3 kan. Okay. 2x negatif 3. Okay, macam ni. Okay. Okay, yang untuk yang ni awak tulis macam ni. Tapi ni saya okay. Sorry pula. 2. Okay, betul lah. Okay, so for equation number 3, number 4, this is how you write your math function, custom math equation. If the power involving is the power or the magnitude for the power is more than 2. Okay, so kalau yang for this, the fourth one, so it's gonna be x u or 4 sum. Okay, so this is the solution for the fourth for the fourth equation. So understand lah. So basically, if you have a complex equation is involving power or square root other than magnitude of 2. So this is how we write it inside the user-defined function in the function block. Okay, and then if let's say that you would like to to do the MATLAB simulating programming without rearranging the simulating block, you can just simply straight ahead write that equation in this block. That one can also, okay, but yeah, it's not well, it's just that you're just going to have less block lah, and you cannot do the troubleshooting on the block. Let's say that you write the equation in the wrong way, so it is actually in text mode, and then when things bad happen and you key in a wrong symbol or wrong sign, and then yeah, that's it. Okay, you cannot find or troubleshoot what's wrong with your equation because you otherwise, because it is in here, it's not outside here. Okay, any question? Faham? Okay, so saya nak tengok siapa yang nak buat volunteer, siapa nak share dengan saya? Sekejap, siapa yang belum tadi? Siapa ni? Faridul Ashraf. Faridul Ashraf, tunjuk awak kat mana sekarang? Faridul Ashraf. Okay. Awak boleh apa? Share screen tak? Terus buat. Jangan buat macam ni. Saya tak nampak sangat. Kalau share screen awak, buka awak punya Google and then share present.
Saya buka dekat phone.
Oh, awak punya ni awak tak buka dekat. Okay. Oh, okay.
Saya pun siap
Ini yang
satu saya. Yang awal-awal.
Lamanya awak buat ni. Awak buat apa? Buat satu pergi mana? Pergi minum kopi kedai sebelah. Lambat sangat ni. Okay, tak apa. Awak buat lagi. Nanti saya dah tengok.
Okay.
Yang sama. Okay, so please lah. Okay, yang lain tolong buat lah. Kalau sebab benda ni simple je. Kalau awak tak boleh nak catch up, sebab tak buat, susah lah. Okay, kalau awak tak boleh catch up sebab saya pergi laju sangat, awak bagi tahu saya. Kata saya laju, slow down. Okay, tak apa. Sebab saya kalau boleh saya nak awak buat, and then kalau boleh sebab benda ni simple, sekejap je. Sebab saya memang saya fahamkan awak dengan dia punya basic je, fundamental. Macam mana nak form simulating block daripada equation yang kita nak. Sebab lepas ni kalau macam bila kita dah awak dah basic, awak dah master, so untuk application lah, so nanti saya nak cerita dengan awak senang lah, awak boleh faham. So nanti kalau awak tak faham yang basic ni pun, saya nak cerita pun susah juga nanti. Okay, so next apa? Fahim, Muhammad Fahim.
Hello.
Fahim. Okay, tunjuk kat saya.
Saya baru siap, cuma belum pernah lagi, so ada sedikit error sikit.
Yang mana?
Saya
Kat mana?
share screen je. Screen, okay. Nampak tak sah?
Error apa?
Okay, saya
Dia kata apa? Okay,
saya ada problem.
Okay, dia sebenarnya kan dia kata apa? Okay, good lah sebenarnya. Saya suka awak punya ni sebab nanti kalau dia ada, saya boleh bagi tahu kenapa jadi macam tu. So tu yang saya suka tengok awak buat kerja ni. So that kalau ada apa-apa saya boleh bagi tahu. So dia kata apa ni? Besarkan sikit.
Undefined macam mana nak besarkan?
Tu maximize dia punya screen. Maximize kan?
Maximize, okay. Power of is undefined. Result of power is undefined.
Itu betul. Awak klik yang biru. Dia pergi ke mana?
Dia pergi sini lah. Function so ni ada problem apa
okay, tak apa. Yang satu lagi yang error yang kat bawah tu dia kata apa?
Okay, undirected. Yang satu dia kata problem kat sini.
Yalah sebab yang awak dia yang bila macam saya cakap lah, ni bagus ni apa, a good example of bad one. Uh, dia dalam simulink, kalau awak pertama kalau awak ada error, dia akan tunjuk dekat mana dan dia akan bagi tahu kenapa. Yang kenapa tu dia memang akan bagi tahu specifically lah, cumanya tinggal kita faham tak faham je. Itu yang pertama. Yang keduanya, sebab awak kena ingat lah, dia punya signal flow dia daripada left to right. So kalau yang permulaan tu dia error, yang seterusnya pun dia akan error lah, dia macam tersangkut. Dia macam apa, ada macam kepala kereta api lah. Kalau kepala kereta api yang kat depan tu dah accident, yang kat belakang pun akan berjujuk langgar belakang yang depan tu. Dia lebih kurang macam tu lah. Yang ni kita tengok di masalah yang 2 plus 4 tu. Yang awak cuba buang 2, awak letak gain. 2 tu awak letak dalam bentuk gain selepas pada block function. Awak delete 2.
Delete 2.
Awak letak, tak apa. Awak letak block gain selepas tu.
Gain kan. Okay.
Letak in between awak tukar value dia 2. Ni sama juga dia punya effect kalau dengan awak multiplication. Cuba run. Dia kata apa? Yang tadi saya memang tak boleh ni. Dia kata pun sama tak?
Dia error yang ini. Saya ada masalah apa je ni?
Tak. Dia sekarang ni cara, maksudnya yang tadi saya tunjuk tak betul lah. So sekarang ni awak kena buat 1 bahagi U kurungan U tu kuasa 2. Sebab ini equivalent kan. So kalau awak double click ni, so cara awak tulis 1 bahagi
betul, saya buat macam tu juga tapi error juga.
Error juga.
Saya buat 1 per 2.
Saya pun
Macam mana?
Saya sama.
Sama
saya buat 1 per 2 error.
Tak boleh try.
Tak apa, saya cuba.
Ada. Dapat something.
Dapat apa? Dia tak error kan?
Tak error, tapi dapat something.
Yalah, something lah. Betul lah dia.
Itu
sebab memang macam ni pun.
Kuasa negatif 4. 1 per betul.
Dia sepatutnya satu. Yalah, dia ada way orang tulis power of negative kan. Sebenarnya kalau negatif. 1 bukan buang negatif. Dia sepatutnya bukan negatif. Buang negatif.
Belum. Dia kat bawah kan. Error tu.
Awak letak 1 lagi kurungan. 2, maksudnya bawah tu. Awak kurungan. Awak letak dekat sebelum U 1 kurungan, belakang 4 tu sepatutnya ada 2 bracket. Belakang 4 tu ada 2 bracket.
Ada 2 bracket?
Tutup kurungan. Betul. Apply. Sekejap, awak cuba apply sekejap. Saya nak tengok dia keluar apa. Bukan itu.
Kurungan tu depan.
Awak ni.
Okay, faham. Sorry.
Macam mana?
Okay.
Sama juga.
Masih sama juga.
Sekejap. Stop. Stop awak punya. Siap.
Okay. Stop presenting.
Ni yang mana? Equation yang mana?
Nombor 3. Saya punya nombor 3.
Tapi tadi nombor 3 bukannya saya dah dapat tadi?
Doktor ada tunjuk tadi.
Tak, yang keempat X kuasa 4, 4X kuasa 3 kan?
Saya kena dekat equation nombor 3 tu je lah. Sebab saya masih tengah update.
Kenapa awak punya error, saya memang tak ada error?
Saya sama dengan Fahim betul. Error juga.
Saya pun sama.
So 3 orang, yang lain-lain ni buat apa? On saja.
Sama je doktor. Error gak.
Betul.
Ada apa error gak sir?
Tiba-tiba semua ada error. Sekejap 2x plus 3. Okay, cara awak nak troubleshoot kan, dia mula-mula paling senang lah. Kita back kembali ke pangkal jalan lah. Okay, ini awak tukar ke constant. Sebab kita tak tahu dia punya salah tu dia buat kita punya equation ke ataupun dekat kita punya continuous input tu. Sebab kadang-kadang ada juga continuous input tu dia tak betul, dia sebab ada yang continuous input tu dia ada yang start sebab dia berulang alik, dia ada yang value yang kosong. So nanti function value kosong tu dia digunakan pakai dalam equation, dan ada setengah-setengah equation, contohnya lah 1 bagi x kan, kita nak kena pakai value kosong tu tak boleh lah, nanti dia ada error lah. Sebab kadang-kadang ada setengah-setengah function dia macam tu. Apa input ini, tapi ini kita cuba balik 2x plus 3. Tapi ini yang saya buat tadi ni. 1 bagi u kuasa 3. Betul je. Fahim, tadi awak buat mana ada negatif 0.4 tadi, saya buat sampai 0.3 soalan ni.
Okay, saya nampak error saya. Saya dah tukar kepada negatif 3 juga.
Dia ni sama lah. So form ni sama lah, satu sama ada kita tukar ni sama lah. So basically tadi saya run okay je, tak ada error. Okay, ni baru betul. Yang tadi okay, macam ni. Sama lah macam sebelum ni. So awak dah run dapat yang negatif 4 tu saya tak tahu lah ambil soalan pada mana.
Cuba try integral sir.
Integral.
Okay, 1 bahagi 3. Okay, 1 bahagi u cos 3.
Integrator letak kat sini, saya just tarik je lah. Okay. See, division by 0. Ini sebab yang saya cakap tadi lah. Betul lah, tadi saya tak nampak dalam punya warning. Nampak kan dalam saya punya ni kan sekarang ni?
Nampak
dia kata division by 0 dalam title function yang ini. Title function yang ni. Betul dia yang ini. Maksudnya sekarang ni kita punya value dalam mana? Okay. So sekarang ni kita punya sign yang kat sini dia macam ni. Betul. Okay, so sekarang ni kita punya function ni dia ada satu u kuasa 3. So maksudnya sekarang ni kita punya value kat sini sebab kita punya value ni dia akan continuous lah. Dia akan dia akan bergerak dari sini sampai sini setiap 0.0 yang tadi kan kita dah we already set our sampling time to 0.01. So at every 0.01 it keep on updating the input that need to be used for the calculation until it reach this one. At this point, this one is value is 0, right? So ini 1 bagi 0 plus 3. So that's why bila kita buat yang ni dia keluar this kind of error. Dia punya division by 0 yang tadi. Ini kalau dia ada cara lagi, kalau tak nak bagi this one, okay. Kalau nak tahu dia tak nak ada error, senang je. Awak tukar balik ke constant. Pakai constant balik. Basically, by right, it shouldn't be no problem. Yeah, just change it to 10. Tak ada error pun. Yeah. Hmm. Ni.
So yang nombor 3 tu dia tukar pada constant lah?
No. The way that we're doing it is correct. It's just that the input that we use is wrong. It's not suitable. Bukan wrong lah, suitable. Because the input is sinusoidal. Because at one time, there's going to be a zero input that will be supplied from the sine wave. Okay, so that's why we got tender error. Okay, so the way that we're doing is right lah. Okay, just the input value that we use. Okay, ni adalah nanti dia ada cara dia. So basically faham So the rest, ada apa-apa soalan? So kita akan go to more interesting modeling after this. Okay, any other question?
No, sir.
Okay, faham So, ni potong kan. Okay, any other question about this one? The basic of derivatives and integral? Any other question? Ada, tak ada. Okay. Next page. Okay, we start now the basic on previously is basic on MATLAB Simulink. Now the main thing of learning MATLAB Simulink is to model a system using the data flow programming approach. Okay, if previously if you only learn about the text coding approach, if you have a system, let's say that a single degree, 1 degree of freedom spring mass system, and you want to convert the response of that mass, how it oscillate on the ground, and then that mass being supported by spring. When you want to do the coding, there's kind of a lot of coding you got lah. Okay, there's a lot of codes or text that you need to write, and then that's not even counted the errors that you need to face. Okay. Okay. But now for this example, okay, example previously example apa? Ni example 2, ni kita consider 3. Alam. Ni example apa? Example 2. 3. Example 4. This is example 5. 5, which is on system modeling. Okay. Okay, this is the key. because through system modeling, basically you're going to learn a lot. So the one that you learned previously is just a basic, and it's just only for involving one by one equation. But what if you have equations that keep on relying on each other, meaning that for the current equation to be run, it will need an input, certain value of input, and that input came from other set of equations. Okay, and then it's like being work in a backward direction. Okay, even though that I told you that the input or the flow of signal that being processed in Simulink, it works from left to the right, but sometimes the input that we use for the next one towards that the left and the right hand side is actually depending on the previous block, or in the future, or the blocks that comes after it. Okay, so that is the key point that is actually a very important thing that you need to understand if you want to model the system behavior using MATLAB Simulink, because if you do understand the concept, then it's going to be much more easy for you to model a system behavior. It's going to be much more easier compared when you want to model with using a coding approach. Okay, so this one I'm using example of spring mass system. It's just that in your in your which year that you learn about vibration, vibration machine?
Second year?
Second year, right? And then during in that subject, you only learn about the single degree of freedom of a spring mass system,
No,
correct?
no, third year, third year.
Third year, third year, saya lepas lah.
Tak, second year, second year.
Second year.
Okay, so you learn about spring mass system, right? Where you have a mass, and then you have a spring, and then you have a damper, and then this is your ground. And then awak tengok lah, benda ni keep on oscillating. Right, this one right? Awak ada belajar kan?
Ada.
Ada kan? Okay. But the one you, where in this one you be introduced to spring stiffness, and then you be introduced to the damping stiffness, damping coefficient, as well as zeta. Right? Damping ratio, right? Correct. Kalau macam if you have more than one, it's going to be, if this is your system response, you're going to if this is your ideal one, is going to damp like this. Sorry. Okay. More than one, if your damping coefficient is more than one, so basically you're going to have a response like this. You naik Allah terus dia ni terus dia settle macam ni. Tapi but if you damping response is less than one, for the same response, you're going to have some oscillation. Sini. Correct. Ada pernah jumpa kan, pernah nampak kan, you did see this kind of response previously, right?
Yes, sir.
Okay, now yeah, that one is actually the result that already being calculated by the books. Now for this, in this subject, I'm going to show you how you can do actually program system behavior that can produce this kind of equation by using MATLAB Simulink. But first, you need to understand the equation, do the arrangement of the blocks that represent that mathematical function or that mathematical equations, and then give the inputs of this step input, and then run. And then you can get this kind of equation. Then from there, you can actually study the effect of damping coefficient. So what if the value is a 0.5, 0.6, 0.7, so you can see the variation of oscillation of your spring mass system. But the spring mass system is the one that not that we're going to do, because this one is too simple. This one only involve 1 degree of freedom. So okay, this one is not even represent. This one's more like a what? Like a ball. Okay, like a ball. Like okay, but okay, this is one. This is actually the one that you learn in your second year. The one that we're going to do today is basically It's 2 degree of freedom kind of system. So this is actually a suspension system that being simplified. So we in the car we have 4 corners, which is 4 tires, and each tire is actually being held by a suspension system one. So instead, when we're doing a modeling, instead of modeling all 4 suspension system at each corner of the car, we only model one suspension at a time. So we only have we call it as quarter car model, where we only consider quarter of the car. So in suspension, we have a chassis, and then we have the wheel that represent the mass, and then in between we have the suspension of that consists of spring and damper. Okay, so basically this is a quarter car. This is the ground. This is the quarter car model. This is the spring stiffness. This is the damping coefficient, and this is the tire stiffness. Okay, and then this one is a sprung mass, and this is the unsprung mass. Okay, let's say that this is your car. So, okay, this is only a quarter car of a vehicle. Okay, and this is a full car, and this is what we call as a half car. Okay, quarter car we only consider this is question. Okay. Okay, for a quarter car, I only consider this one. I only consider this tire only. Okay. So if I just take a look on side view, so you're going to look like this. Okay. And then in between there's a MacPherson strut. So you have the shock absorber with a spring. Okay. And then the sprung mass is actually the chassis or the weight that being supported by the spring. So meaning that this one, everything over here. This is what we call as a sprung mass. Okay. And for the unsprung mass, MU, everything including everything that not being supported by the spring, and that include the weight of the spring and damper itself. So downwards lah yang bawah ni. Okay. Oops. Oh, tak ada color lain. Okay. This is the unsprung. Okay, this is the unsprung mass over here. So this mass being represented by this one, and then this one being represented by this one. Okay, the spring and tire, sorry, the shock absorber and the damper is actually being represented by this one. Okay, this is spring and the shock absorber being represented by this one. This one. Okay, for tire, because we know tire is actually made from rubber, and rubber is actually stiff. So the tire being modeled also can be modeled as a spring. So this one. Okay, understand about this quarter car model, because you are in the third year, you're supposed to learn about this only in fourth year in vehicle dynamics. That one only if you're taking vehicle dynamics lah. I'm teaching vehicle dynamics. Okay, understand about this diagram?
Yes, doctor.
Yes,
Okay,
doctor.
good. Okay, I'm going to undo. Now, to make a modeling, basically we need to really understand the equations. Either you understand by deriving the equation of a system, or you just simply take that equation from technical paper. Okay, there's advantage if you are able to derive the equation on your own, because you're going to really understand about it. But if you take the mathematical equation that represent a system behavior from technical paper, and then usually you're going to take some time lah to read and understand what does those equation means, and then that one thing, and then understanding one thing, and then to do the rearrangement of the equation is another thing. Usually you're going to involve in complex, because usually in technical paper they're not explaining the equation thoroughly. Okay, there are missing points. Okay. Okay, back to this example. Usually for quarter car, so this is the, so I'm going to derive the equation. So this is what we call as a sprung mass. Up here it says sprung mass. Oops. Here. Okay, this is the sprung mass. This is the unsprung mass. Okay, this is, sorry. Okay. So we're going to do the derivation for the sprung mass first. Okay. So basically we're going to do the free body diagram for the sprung and unsprung mass. So if we, for sprung mass first, this is the block of sprung mass, and this is the the spring force and the damping force, and if we draw the reaction force, so basically you're going to point upwards. Okay, we have the spring force, and then we have the damping force. Okay, so in terms of equation, summation of forces equal to ma. Okay, this is ms. So you're going to be positive outward, so you're going to be fs plus fd plus ms. So this A is actually the acceleration motion of this sprung mass, and we write it as a ZS double dot. So double dot means that it's actually the acceleration for this sprung mass. So this is our first equation. Okay. Second one, we're going to derive the equation for the unsprung mass. So this is the free body diagram for the unsprung mass, where the this time sees that we're going to the direction of the forces is going to be in opposite direction, because we are using the considering the Newton's third law, where there's action, there's going to be reaction. So since that we already consider that the sprung mass, the direction of the force is upwards direction, so when we pull out and do it separately, so the direction is going to be opposite, because it is going to be the reaction of this one. Okay, so meaning that we're going to write the direction of the forces downwards. Fs, Fd, and then we have Ft. Okay, so same thing, summation of force to MA. Going to take both direction as a positive. So this time you're going to be FT minus FS minus FD is going to be MU ZU double dot. Okay, this is the second equation. Now, since that we already have, this is what we call as general equation. Now we need to define what is FT, what is FS, and what is FD. Okay, so basically FT is actually tire force, and it's actually a function of relative motion between the tire itself and the ground being multiplied with the tire stiffness. Okay, so we have the KT. So ZR is our road input minus with the unsprung mass vertical displacement. So this is the third equation. Okay, now we need to define what is Fs. So Fs is actually this one. It considers the motion between the sprung mass and unsprung mass. So we need to use Ks Z U minus Zs because it is in between the sprung mass and unsprung mass. So compression and extension of the spring, we consider is actually the displacement of absolute absolute displacement between the unsprung mass motion, unsprung mass and the sprung mass. Okay, so it gave us this one. So spring force equal to spring stiffness multiplied by the differences between the unsprung mass and the sprung mass motion. So this is the fourth equation. The fifth equation is the damping force. For damping, we use damping coefficient and relative velocity because you learn in your vibration and machine subject where the damping force is actually being given by the FD equal to CS V CV, right? Correct or not?
Yes.
Okay. Okay, now we use a dot for velocity for unsprung mass and sprung mass velocity. Okay, now we have 5 equations, and these are the equations that we're going to model it using Simulink block. Okay, okay, this is important. Okay, now we have this equation. The first rules when you want to model system behavior, the mathematical equations of it, you need to remember. Okay, this is the rules number berapa? Nombor 3 Sebelum ni kita ada rules apa? Okay, okay, rearrange. We have two. The third rules. Always start with the most general equation before to details. Okay, always start with the most general equation before narrowing down to details. So what I meant is that, okay, this is your general equation, equation number 1 and equation number 2. Okay, equation number 1 and equation number 2. And then in this equation, we actually would like to see the motion, vertical motion of sprung mass and unsprung mass, which is the acceleration, which is this one. Okay, Zs and Zs double dot and Zu double dot. Okay, this is the general equation. So inside of the first and second equation, we have Fs and Fd. Okay, before we go through, we go to up to get the Zs double dot. We need to move this ms to the need going to be under the going to divide the Fs and Fd. Okay, so this Fs and Fd is the one, this one. Okay, so to model your simulation model using a Simulink block, you need to model the first equation and the second equation first, and then followed by the third, fourth, and fifth equation. Okay, understand? This one. Always start with the most general equation before narrowing down to details. Okay, understand these rules.
Yes, doctor.
Okay. Excessive. Okay, now we're going to model it. Okay, we start with the first equation, which is the Fs. Okay, the first equation, this one. Fs plus Fd equal to Ms Zs double dot. Okay, this is the first equation. Okay, the issue is that we want to make Zs double dot as our output. So in order to do that, we need to move this Ms to this side. So it's going to be like this: Fs plus Fd divided by Ms. Then we can get Zs double dot. Okay, and then from this Zs double dot, later on we can get this is actually the acceleration, and then to get the velocity. So basically we're going to do single integration, and then for displacement we're going to do double integration. So meaning that the data from double integration of acceleration data. So meaning that we need to have another another integrator after the velocity block. Okay. So this one. Okay. So I'm going to make it for the first equation. So start with gain. So this one is going to be 1 over ms. So this block is actually in the red color because we haven't defined the value for ms. So the output from here is going to be acceleration or Zs double dot. Okay. And then this one need to be sum. So plus plus. So this one is going to be Fs. Okay, understand? This is actually the blocks that it's not a full block yet, but the arrangement that possibly represent the first equation because we haven't defined the Fs and Fd yet. Okay, understand? This the arrangement of this block. Okay, we have the Fs plus Fd divided by over ms, and the output is the S double dot. And over here, we're supposed to put display or scope, but we're not going to do that yet. Okay, any question?
No, sir.
No,
Okay,
doctor.
good. Okay, this is the basic. So I want you to try. Okay, I'm not going to finish this one, but instead I'm going to draw the layout in the upper board. I want you to do it on your own. Okay, you copy your layout and then just uh, try to build. Um, okay, it's gonna be one. One over ms. So it's going to be the gate. Yep. Okay, this is the first block. So we have the gain, where inside this gain is actually 1 over ms. So this output is actually the ZS double dot that being integrated to get the velocity, and then we integrate another time to get the displacement. Okay, so same thing. So I'm going to put the 1 over mu. So I'm not going to write it inside the triangle, because if I did, the triangle need to be need to be bigger, and then I'm afraid I'm not going to be able to put everything in this space. Okay, so now we have the okay, but for the second equation, the spring and damper are going to be going to have a negative sign, negative, negative, and then the positive for the tire force. Okay, so for the FS, we just simply pull it from here, and then for FD, we just pull it from here. Okay. Okay, then this is our FT. Same thing from here. We have 1 over S. We have 1 over S. Over here we have ZS double dot, ZS dot, and ZS. Over here we have ZU double dot, ZU dot, and ZU. Okay. Now we would like to define the value for the FS. So FS is actually gain. So we have KS plus minus of ZU and ZS. So since that we already have the ZU, the ZU is no, ZS and ZU is over here. We just can in Simulink we just can simply pull it out, or pull the signal line over here. But based on this arrangement, it's going to be haywire lah. So to make things easier, since that ZS is already in over here, so we just pull ZS from here. So we just change the subscript here. So it's going to be ZS, be ZU. Okay, then we change the sign. So negative, positive. Pull the signal over here. Then complete loop. And then for ZU, we just pull, tarik je, and take it over here. Okay. Same go for the FD. So this is the CS. Plus minus. So I'm going to use a different color. So this one I'm going to take ZU dot and ZS dot. So I'm going to pull the signal line from here. So for ZU dot is over here. And ZS dot is over here. Okay. And then now it's for the FT. Same thing. We just need to multiply with the gain. So this one is KT. Minus plus of ZR. Okay, ZR is going to be our input, which is we need to use a step input block. And then for ZU, we take it over here from here. So different color. Just take it from here. Okay, this is actually a complete system. So I want you to try this one. Try to make this block of a cortical model using this parameter. Okay, DKS, the value for DKS, MS equal to 850. Sorry, 250 lah. MU KS ni 1500. KT okay. Inside here is actually a step input. I want you to change the step input. This one. Okay, just later on you need to click the step input and change the value at 1 second. We assume that this cortical going to start hit the step input going to start going up at 1 second up to 0.075. Okay, t equal to 1. The final value is ZR, which is equal to 0.075. Okay, I'm going to show you this block for H. Okay, this is the step input. Sources. Okay, this is the step input. Use this value. Okay, the step time. So meaning that the step time meaning that at what time that the signal is going to go up. So it's going to start go up at 1 second. So initial value is 0. You're going to move from 0 to 0.075. Right. Okay. Okay, use this value for your so you don't change this one. Okay, you need to focus this one and this one. Change this value at these two field only. Input first. Okay, any question about this layout?
Sir, the mass S and mass U need to convert into Newton or put it direct.
Directly. Just use key in the value straight ahead 250 because everything that been derived here is we are using SI unit. Everything's already in SI unit.
Okay, noted.
Okay. This one change not okay, tak apa, pakai dulu 250. Nanti ubah. Okay, any question?
What is it called again? That block step input.
Step input. You can find it in the sources.
Sources, okay.
Okay, ada block ni.
Saya masih tengah cari. Oh, nampak. Oh, this step.
Okay, ada.
Ada.
Okay. Okay, any other question before we end our class? Any question? Understand? Okay. Tak ada
Tak ada, doktor.
Okay, then tak ada, then so we will end our class. So see you next week. So please do this first because if you do it, we will know either you really understand what I'm trying to teach you or not. Okay, if you try it but you still cannot do it, then it's okay. We're going to discuss what's wrong, what went wrong with your model. Okay. Okay, and then in your before that, okay, make sure that you put Okay, later on, I want you to put the scope over here. Okay, this is your scope. I want you to put your scope over here. Sorry. Different color. Okay, blue. Scope. Over here. Just tap the signal over here. So this is the scope for your sprung mass response. So roughly, you're going to get a result like this. So this is your ZR. Your ZR is actually in a form of step input. This is your ZR, your scope. It's going to look like this. And your ZS is going to be like this. Okay, this is your ZS. You should expect it's going to oscillate like this. Okay, this is your ZS. Okay, if you get this answer, after you put the scope block at the ZR and ZS, and then you're doing a correct model development of a quarter car. Okay, understand?
Understand, Doctor.
Okay, good. So I'm going to share with you the notes. Okay, the notes will keep on updating. So even that you see that this notes number 2, number 3, it's just a continuation from a previous note. Okay, if you have no other questions, so we dismiss the class. Okay, Assalamualaikum and good evening. Okay, thank you.
Thank you, Doctor.
Thank you,
Thank you,
Doctor.
Doctor.